All right, coming up next, we have Narceo Vaina Rodriguez with ICSI up here to talk about the Netalyzr program.
So, where is the controller for the slides? Okay. Okay, perfect. Well, good morning, everybody. So thank you for the introduction. And before getting into more details, I would like to thank you for attending our talk. And also, I would like to thank the program committee for giving us the opportunity to present Netalyzr to all of you today. So Netalyzr is a network debugging tool that tries to analyze the networks beyond the radio link, especially in the case of mobile. And we try to characterize and identify aspects of the networks that have not been quite well explored yet, such as the effect of middle boxes or even the business relationships between operators. And this work has been done in collaboration with my colleagues Srikant Sundaresan, Christian Kreivig, Nicholas Weaver, and Bernd Paxson from ICSI, as well as in collaboration with Moritz Steiner from Akamai. So for those of you who might be wondering who is this guy talking to you today, let me give you some background about myself and my lab. So I'm a research scientist at ICSI in the networking and security group led by Bernd Paxson. And ICSI is a nonprofit research lab affiliated with UC Berkeley. And before that, I was actually doing my PhD at the University of Cambridge with John Crowcroft in collaboration with Telefonica Research. And my PhD topic was about identifying cross-layer inefficiencies between mobile applications and cellular networks, and how they are actually causing trouble in the networks in terms of signaling as well as in the battery life of the device. And now let's move into the juicy bits. So since 2009, we could see more or less how the internet is actually becoming mobile. More and more people are accessing the internet from mobile applications and mobile devices. But actually, this kind of networks are having limited resources. And actually, the deployment is expensive. Operators have to pay for the spectrum license and also to deploy quite expensive equipment. But in any case, they're trying to catch up with users' demand, but it's still a bit unclear how these networks are performing in reality. And as we could see in the keynote, there are certain applications and other organizations that are trying to benchmark the performance of the networks, but they are usually using classic techniques such as latency tests, trace routes, or throughput. And some examples are, for instance, the FCC's speed test, other academic research projects such as University of Michigan's MobiPerf, as well as Ooklas speed test. But we wonder if this test of tools actually reveal which one is the underlying issue that is affecting mobile performance. And for those of you who are not familiar with this popular infographic, it's actually a quite interesting analogy with what's happening on the internet. It has been designed by Charles Minard in 1869, and it shows how the Napoleonic troops decreased in size as they were marching from Kaunas in Lithuania to Moscow when they were trying to conquer the Russian Empire. So here you can see that some troops got killed on their way, some of them got redirected somewhere else, and also some troops were waiting for others to join them in the retreat. And as I said, this is a great analogy with what's happening on the internet. If we take a look at what a user may actually think when they're trying to reach some online servers, is that basically they think of a cloud sending bits back and forth. But there are a lot of middle boxes and other elements on the network that can affect performance. So we may have packet drops on the radio link. We may also have issues because users are having data plans that may have volume caps or throttling thresholds. But there are also other middle boxes, such as DNS resolvers or proxies, that may block some content, as well as redirecting it somewhere else. But as Napoleon discovered, the way actually was hard, but it's even harder the way back. We have firewalls, we have NATs, and we have also caches. So as you can imagine, if we want to really see which one is the root cause causing trouble in the networks, we have to take into account a lot of elements. So that was the reason why we wanted to build a tool capable of penetrating mobile networks in detail in order to identify all these issues. And for that, we took advantage of our ICSI's Netalyzr tool and we customized it and adapted it to the mobile context. So this allows us to have a very detailed information about the performance deployment and also about the features of mobile networks in the wild. And let me also give you some background about the project for those of you who are not familiar with Netalyzr. So it started back in 2009 as a tool that aimed to diagnose connectivity characteristics and trouble in the network. And we actually aim to use the the mobile device as the vantage point, and we exploit crowdsourcing techniques in order to collect as much information as possible and also to have as much fidelity as we could on the data. And one of the main goals of the project was making this tool available for anyone independently of their technical background. And that's still a quite hard challenge for us, as we're trying to explain to users the different characteristics of the networks as well as how they can fix the issues that they're encountering. And since 2009, Netalyzr was run more than 1.4 million times in 170 countries. So this basically covers almost every single ISP in the world. And as our initial deployment was based on a Java applet, we could not penetrate mobile networks as it was running on the browser. So we decided to port this tool to as a native Android application, and it was actually released in Google Play and Amazon App Store in October 2013. In the case of the mobile app, we have already around 22,000 installs with quite optimistic reviews. And we have access already to 400 mobile operators in more than 120 countries. And what we do with this data is basically what academics do, just writing papers. And I will encourage you to visit our website if you want to see or to get more information about the methodology of the different tests, as well as some results. And we have actually published this data in conferences such as IMC, PAM, or Connext. And some of these works actually cover from TLS certificates deployed on Android devices up to the effect of proxies on DSL connections. So the tool executes around 120 different tests. And the tests begin to be executed whenever the users click on the start button. Unfortunately, we don't have access to the radio information, as the control plane is completely hidden from the firmware to the operating system. In any case, we have a very comprehensive list of tests that are trying to benchmark and characterize the IP core. So we look at, for instance, the DNS resolvers. We benchmark their performance. We also look for support of new technologies such as IPv6 or DNSSEC. We also run different tests to estimate, for instance, buffer load, or in order to identify as well certain aspects of peering, NAT behavior, and even, for instance, the behavior of hidden proxies and HTTP proxies. But in addition to that, we also look at handset misconfigurations. So we are looking, for instance, at what kind of APN settings the devices are having, or which ones are actually being used by the device. And the APN settings are actually quite important for us, as they determine in a quite good detail the way the network is going to behave. And as I said, we also check for certificate for the root store of the different devices, seeing how mobile operators as well as different vendors increase the root store, and also other configuration aspects such as the clock drift. Then once the tests are completed, the server captures and collects all the information, and we compile this information to generate a result summary that is sent back to the device. So we classify the results based on their severity, and also depending on the type of test that actually is running. And then users can actually click on the results if they want to understand or to get some information about what the test is actually doing. And now that you have a high-level idea of what Netalyzr does, let me present a few preliminary results. So first, I will cover how middleboxes and DNS, for instance, DNS resolvers and HTTP proxies are deployed in the networks and how this can affect the user experience. And after that, I will show a few numbers about how IPv6 is currently supported in mobile networks. But I will conclude with some results about the layer 8. So basically, we have identified how business relationships actually between mobile providers and also how new business paradigms, such as mobile virtual network operators, are changing the whole ecosystem and also providing different type of services to the customers. So in any case, we will be glad to hear from your feedback, and also we would like to hear your suggestions if in case that you may think that there is something that is actually inaccurate. And for those of you who are not familiar with cellular networks, I will start by describing a bit the classic or the theoretical deployment of a cellular network. So a mobile network is divided into planes. First, we have the control plane that basically is responsible for spectrum management, mobility management. And then we have a data plane where we actually send the user's data. And then in the data plane, sorry, I was missing that. And then in the data plane, we have the middle boxes, such as the DNS resolvers or other elements such as the NATs. A mobile device or a user equipment is actually connected to the internet after creating a PDP context. So this is basically a tunnel that hides completely the control plane from the device. And mobile users actually have very little power to modify what kind of middle boxes they are going to encounter whenever they're trying to connect to the internet. So as we can see in this figure, the position of the middle boxes also affects the performance. In this figure, we compare the DNS lookup time depending on whether the DNS resolver is placed before the carrier-grade NAT, so in other words, as close as possible to the device, or after the carrier-grade NAT using third-party services. And this test is actually instrumented to warranty that the names that we are looking for are not cached. So basically, they are going up to our authoritative name server. And as you can see, most mobile providers actually, most mobile providers actually deploy their DNS before the carrier-grade NAT. But when they don't, actually, it will affect significantly performance. So it can increase around 90 milliseconds the DNS lookup time. And if you think about the way mobile applications behave nowadays, fetching content from CDNs and from a lot of cloud providers, this can actually become a significant bottleneck for mobile performance. And in fact, there are also middle boxes that remain hidden for most users. And one could argue that middle boxes are actually deployed for a purpose. They are usually used for to combat address space depletion, such as in the case of NATs. They are also deployed for security, as in the case of firewalls, or to fight resources scarcity, rate limiters, or also to improve performance, as in the case of proxies performing TCP splitting or performance-enhancing proxies for HTTP traffic. But this figure, as we can see, shows that in the US, most of the operators are actually having DNS proxies as well as HTTP proxies deployed. And the numbers that we are seeing are actually way higher than in the rest of the world. So what are these middle boxes actually doing to our traffic? Well, I could tell you many anecdotes that we have observed in the last year, but as you can see in this figure, most of the proxies are actually modifying the HTTP headers and more significantly the content. And if you think of, for instance, the case of a professional photographer trying to download an image from a high-resolution image from a given website, the network is actually likely to transcode the image to a lower resolution one. So this can actually affect the user experience to some extent. But the most significant aspect that we have observed is that there are a significant number of operators that are actually having a proxy with a vulnerability that was already identified in 2009. So it's a 5-year-old vulnerability. And despite the fact that this vulnerability doesn't affect the user security, it may actually indicate that there are other bugs and other issues behind these middle boxes. And now I want to basically present some preliminary results about IPv6. And unfortunately, the data is not very conclusive. But I would like to hear from you about which one are your experiences when you're trying to do the transition from from IPv4 to IPv6. And as you can see, IPv6 support is still quite testimonial in mobile networks. we have around 11% of the sessions coming only from 9 operators in 6 different countries. And this is actually very exciting for us, as we have the ability to see how IPv6 is deployed since the beginning. And we are very excited about what kind of results we will see in the upcoming months. In any case, we haven't seen any difference in terms of performance so far when we are seeing devices connected through IPv6. But the problem is that whose IP core we are actually measuring. We need to take into account the layer 8 of the protocol stack. And as some of you may know, there are 2 types of mobile operators. There are mobile network operators who are actually having a spectrum license and they actually deploy the whole infrastructure. And there are also mobile virtual network operators that run on top of a mobile network operator, and they can actually use completely the IP core supported by the main carrier, or they can actually deploy their own. In addition to that, mobile operators also share infrastructure between them in order to reduce the network deployment costs. And this happens a lot in a lot of European countries. And when network sharing is taking place, we can see that some operators are actually implementing home routing. In this case, all the users' traffic is sent to the home network and actually increasing the latency, or they are implementing local breakout. In this case, all the users' traffic is sent through the visiting network, and therefore the user is vulnerable to any middleboxes misbehavior, or actually their performance can improve, depending on the type of network that they are actually roaming to. But unfortunately for us, all these business relationships are not publicly available. And what we will show you in the next slides is basically based on observations that we have seen with Netalyzr. So this is a partial view of what we see in the US of the mobile ecosystem. And here we can see the 4 main mobile carriers having the spectrum license at a national level. So Verizon, Sprint, AT&T, and T-Mobile. And we can easily identify as well the mobile virtual network operators running on top of them. And this is just a small subset of the ones that we have observed just because of space limitations. But the really important aspect for us is that we have seen devices with a SIM card provided by one of the operators, but actually running completely on a visiting network. And actually, this is what what we're actually really trying to characterize at the moment, in the sense that we would like to see how this can affect the user experience and the performance. But in addition to that, there is also a 3rd type of service. And one example is WDSPC. And we tried to contact them just to find out which one was their business model. And according to their website, they are leasing IP address space. But what really surprises us is that 2 of the mobile operators that are having a lot of IP address space are actually taking advantage of this kind of service. And another type of service is what we call mobile virtual network enablers, or cloud providers to some extent. And in this case, we have seen some mobile virtual network operators that are actually taking advantage of this kind of service to deploy completely their own IP infrastructure there. But as a result of all these business relationships, we are actually able to identify heterogeneous behavior within a network. So this figure shows the percentage of sessions of 2 operators with a particular network behavior. And as we can see, operator 1 sessions are always having the same behavior. But in the case of operator 2, they can differ. And this can be caused by different network deployments in different parts of the country, or just by different APN settings. So for instance, we have identified one user who was actually entering by inappropriate APN settings on his device. And this was forcing many applications to crash, as the proxy that it was reaching was forcing compression by default. And if the developers are not handling this kind of feature on their HTTP libraries, then it's very likely that if they don't handle the exceptions properly, the applications may crash. And then what we have observed is that when these users are roaming on a different network, we can see that the users of a given operator are actually getting properties from the network they are visiting. So this corroborates that the fact that these operators are implementing local breakout, and therefore they are not warranting to the customers that an homogeneous quality of service. So to conclude, let me basically finish with a couple of takeaway messages and also some lessons that we learned while trying to characterize mobile networks. In order to actually benchmark and characterize mobile networks, we definitely have to do it from the edge of the network. If we're trying to do anything from the cloud, then basically, so for instance, using traces from servers, we will measure whatever is happening between the middle box and the server, and not between the mobile client and the server. And then we also have to take into account a full cross-layer analysis, looking at every single element of the network, including, as you could see, the business relationships. In fact, these business relationships and their implementation can also impact on the network properties. So we need to look for very fine-grained information on the device in order to accurately map this information to what we are observing. And we are actually aware of the fact that we are not able to fill a lot of pieces on this, basically, on this space, and we would like to hear from your feedback and your suggestions in case that you may be aware of something that we are not actually measuring. And we are actually continuously supporting and deploying new tests on the app. In fact, I think it will be very interesting to characterize, for instance, the mobile ecosystem at a worldwide scale, just to identify different policies depending on the regulatory bodies that are controlling the market in these different countries. And a good example is actually what will happen as well, for instance, comparing the performance that we are seeing in the US with the performance that we are seeing in more liberalized markets, as in the European Union, where the presence of mobile virtual network operators is actually quite significant, and also they are supporting roaming between different countries. And in addition to that, we will also like to have a better insight on what will happen, for instance, in the mismatch between DNS resolvers and CDNs. So for instance, this is actually caused by the fixed infrastructure and the limited number of gateways that we will see on mobile networks. And that can actually, for instance, for a couple of operators, we have seen that in many cases, the CDN that is being requested is actually not the ideal one, according to other sources that we are actually able to obtain. And in any case, that is the end of my talk, and I would love to invite you to try to run Netalyzr, and preferably if you can run it on a cellular network, it will be better, so we can collect more data. And we would like to hear from your feedback, and also in case that you have any suggestion or any recommendation or anything that you would like to measure, please get in touch with us through any of these emails. Thank you.
We have a couple minutes for questions. Any questions? Thank you very much. You're welcome. Thank you, Narceo. All right.